So I'm Leo Reiter. I run technology strategy and product development for Nimbix, and I'm actually here to talk to you about the missing middle. We've heard him referred to a couple of times today. It's actually an IDC. It's a big IDC term, so thought I'd point that out. So anyway, this presentation is really based on years of conversations with customers, prospects, as well as fellow thought leaders. So it's not like we just kind of did compile statistics. Like, this is actually based on information that we get when we talk to customers. And obviously it's through our lens, but you know, we can only talk to the customers who we talk to. So generally speaking, you know, when we look at the market, we see the status quo, which is typically workstations, sometimes small clusters, you know, of people that actually need HPC. And then of course, on the right-hand side is kind of the nirvana, the large, you know, labs and centers and so forth. And I know I missed a bunch of them. I just didn't want to pollute the slide with 100 logos, but you know who you are, and I apologize if I missed you. But basically, the addressable market is somewhere in between, right, when it comes to actually enabling HPC for new users. And to borrow a marketing term, we call them the pragmatists in pain, which is also known as the missing middle. And these folks, they're not passionate about technology one way or the other. They're passionate about what they're doing, which might be some kind of product development or design or whatever it is. And they're not zealots. They don't care if it's, you know, this type of interconnect or that. They just need to get their work done. And by the way, their work's due on Friday, so they can't spend 6 months debating as to what they're going to build or who they're going to buy it from. So in very general terms, when we think about, you know, the missing middle is generally underserved. When you look on the end user side of the market, ISVs are typically focused on productivity, not necessarily performance. And these folks are really running gigantic workstations that just take like 2 weeks to run a simulation or whatever it might be, or clusters that are oversubscribed. And the end user vendors are not really speaking to them. And then on the HPC focused vendors, I mean, ultimately we're all kind of focused on exascale, and that's great. We need to get there, but again, it doesn't mean anything for the guy who needs to get his simulations done by Friday, right? So they're underserved on both ends of the market. And then on top of that, they're under pressure. So why? Because product cycles are getting shorter, product releases are getting more frequent. This is true with no matter what you're building, especially if you're selling to consumers. They expect everything yesterday for free. And on top of that, there's lower barriers to entry to even design and build technology or any kind of product. So what it means is that there's more competition, because now more people can do things that years ago only a select few could do. And of course, that means that now people need to differentiate so that, you know, kind of the basics don't cut it anymore when it comes to designing products or solving problems. So they have to, you know, innovate on features and do all these things. So that increases complexity of what they're actually working on. So that all adds to the pressure of the missing middle. And then finally, understaffed. We all understand this. Scarcity of skills is a huge problem. Usually when you talk to people, they'll tell you how bad the economy is and how people are out of work. But when you try to hire someone, you can't find anyone qualified to do the job. And I know this is a kind of a small section of the world, but in technology, I think that's a very consistent theme. There's a scarcity of skills, especially with specialized skills like HPC. I mean, most of the technology market is focused on information technology, on commodity skills. HPC is a very rare skill set, right? So when we're trying to hire these people, they're very difficult to find. And even if we do, the really good talent, the one that's going to get you your work done by Friday, is really hard to find, right? Now you add in millennials who expect to be promoted to CEO within 6 months of being hired, and you have to kind of balance that out while you're weeding through the workforce. And of course, your budgets are shrinking because, you know, for a number of reasons. I mean, skills are more expensive. The economy does slow down in certain sectors, so that means we have to do more with less. So that all equates to being understaffed. So if you think you're going to get help to get priority for your problem as the missing middle, it's probably not going to happen by Friday or anytime soon for that matter. So let's think about some myths that, you know, not everybody believes this, but we do hear these things from time to time. When we say that we cater to kind of the mainstream market, they're like, oh, they're just running small jobs, or they don't understand HPC, or, you know, they're just kicking tires, or they're just doing simulation, they're really not that sophisticated, all these different things. It's really easy to dismiss the needs of the mainstream when we're so focused on the high end of the market as a community. So the reality is that these myths are really not true. Of course, there are some segments, some people in the market that do fall into these categories. But generally speaking, these are actually real people. And by the way, they're in every single segment in every industry that you can possibly imagine, right? So even you may not think of large enterprises as a missing middle, when you start looking at use cases and departments and all these different things, they don't all need to run 16,000 core Fluent simulations all the time, right? That would be what a national lab does, let's say. So these range from entrepreneurs and contractors and kind of knowledge workers that are independent all the way up to large enterprise, defense, government, et cetera, and then a whole swath in the middle of departmental, mid-enterprise, project-based teams that may be within a large enterprise, but maybe actually smaller teams. And of course, when you add the distributed workforce in, if you were to even procure a supercomputer, where would you put it? I've got teams in 20 different countries, right? So how do I make sure that their data gets there and so forth, right? So these are all real problems of the mainstream market. So if we think about it horizontally across all industries, we see three categories of people who fall into this space. First is the ones who actually need HPC but don't have it. And there's a number of reasons why they don't have it. They probably don't have the skills to actually deploy it, but more importantly, if they just spend $10,000 a head on workstations 6 months ago, and they try to go back to the CFO saying, you know what, these workstations are too slow, we've got to spend $1 million on a cluster, the guy's going to be like, why did I just spend $1 million on workstations 6 months ago, right? So the budget, those conversations, especially in today's climate, are really difficult to sell, right? And on top of that, there are software license gaps. So the workstation license for your solver is way cheaper than the HPC version of the solver, and procuring the license is not always that easy as well, right? Then there are those who need HPC and already have some in-house, but as we know, and we've heard it today time and time again, in-house clusters are almost always out of capacity, jobs are queuing. It's difficult to get priority sometimes to get your work done, right? If the workforce is distributed on different networks, then maybe it doesn't do you any good to use that cluster because it's just the latency is too high or whatever it might be. And on top of that, the infrastructure is probably obsolete. So it may not even actually be faster than your workstation, right? And that's just something to consider. And then the final category that we find really exciting, and we think there's a lot of potential here, is the ones who actually need HPC but don't know they need it. These are non-traditional HPC use cases. Obviously machine learning, HPDA, et cetera. So again, when these customers come to us, they come to us asking for a bunch of GPUs. They're not asking us for HPC. Well, guess what? If you need 500 GPUs, you pretty much need HPC. I mean, that's just a fact, right? You're not going to get that from a workstation. So this is a whole segment of the market that's growing now that actually really needs HPC, but they don't really think about it as HPC, right? So if we think of digital transformation as having taken the physical model, and not completely away, but reducing the number of physical models we need to build and replacing that with simulation, then what does the status quo actually transition to from the compute side? And of course, we think that it's going to be cloud for a good portion of that. And the analogy that I like to use, and it's kind of very different, but if you think of the developing world, when they actually embraced modern telecommunications, they didn't go to like touch tone and then fiber and then this. They went straight to mobile, right, from their aging copper infrastructure. So there was a phase shift because they just bought the latest and greatest. So if I'm a new company and I'm looking for to actually deploy new infrastructure, and at least the CIO looks at megatrends and sees, hey, cloud, that's the big megatrend now. That's the mindset that's going to start dominating and saying, you know what, why do we need to make all these investments up front when we can just go off and effectively use the capacity on demand? So we think that for many companies, there's going to be an actual jump from building their own HPC infrastructure straight to cloud, right? So how does the missing middle win with cloud? You heard this all day long from like 3 different people. I don't need to read this to you, or maybe 4 or 5 different people, I should say. But basically, one of the things that I really want to highlight is the turnkey workflow and software as a service specifically. From our perspective, is a must for the pragmatist in pain. Because if you go to somebody who's running an application on their workstation today, and they say, well, I need HPC, and you say, okay, well, here's a cluster, go set it up, that's not solving their problem, right? So what they end up doing is finding a consultant or a broker or somebody to help them out with it, because what they actually need is a way to run that same application, but with 512 cores or 2048 cores instead of 8 cores, right? They're not looking to build HPC infrastructure. So it's very important that they actually can buy that class of service, again, to get their problem solved in a very short period of time. But then what about the ISVs, right? Well, again, we heard this mentioned earlier. So ANSYS actually announced elastic licensing very recently. Full disclosure, Nimbix was a part of the elastic licensing beta. So we've been working with ANSYS on this for a very long time. We never thought it was going to happen, but it actually happened. So they actually embraced, they said, you know what, cloud is actually has a purpose. Like, we still want to make sure that you buy, a lease, or that you lease software from us, but we understand that you may not be able to predict all your usage, and you may actually need more than you bought periodically. So, and that is a cloud concept, whether you're running a private cloud or a public cloud, the ability to scale up and down is a cloud concept regardless. For the main customer quoted there, which by the way, Avid is a Nimbix customer as well, it was all about flexibility. And for them, it meant, how do I manage multiple teams with simultaneous projects? I have no idea how much I'm going to need from month to month. My needs are always changing, so I can't really predict scale up front. So, and these licenses are actually really expensive. So it's not a matter of kind of guesstimating and buying more than you need. I mean, that makes a big impact on your bottom line, right? Now, there are other vendors in the space, like CD Adapco, for example, that already offer on-demand licensing. So it's not just, we heard this before, that the market will slowly transition to this. And we think that pay-as-you-go will become the go-to model for new ISVs, right? Think about, anything that's happened in the last few years. If new companies are coming out and building new codes or whatever it might be, they're probably they're born in the cloud age, right? So they're going to be looking at subscriptions and pay-as-you-go as the go-to license model because they've never built off-the-shelf software. They've never built software that you download or that you buy in a CD and install. They built it in the cloud to begin with, so how else are they going to sell it? I mean, this is kind of the default, MO that new companies are going to use. But obviously, the traditional ISVs, we believe, are going to transition as well. And in fact, we're already seeing that certainly with ANSYS and of course with CD Adapco. But of course, there are challenges for HPC in the cloud. Performance is not always as good as dedicated HPC. So we understand that embarrassingly parallel algorithms scale really well horizontally in the cloud, and we've heard that many times today. But we also understand that tightly coupled ones, in some cases, not so much, right? The sticker shock, so yes, there is unlimited scale, but that also brings unlimited spend, right? So there's all kinds of things that have to be done, when you do start embracing cloud, because the meter actually runs as long as you let it at any scale you want, right? And that's great when you need it, but it's something that you now have to deal with that's a little bit different than when you're out of capacity, right? And it may actually still require retaining or acquiring HPC skills, because again, if you're buying a kind of a cluster on demand, you still have to load the software, you have to test the workflows and do all these different things. So again, this is where class of service comes into play, right? So there are HPC clouds that actually rise to the challenge, right? So how do they address performance? Well, there's real HPC architectures. There's high-speed interconnects, high-performance storage, co-processor accelerators like FPGAs, and then of course high-density and large memory systems are available from some vendors. Sticker shock, well, that can be solved with different pricing plans. And actually, if we look at the telecommunications industry, they do a really nice job with the cell phone plan. So you're basically buying dollars at a discount, right? You commit to a certain amount of usage, and then you have the flexibility to burst. And of course, they tell you when you're about to go over so that you can commit to more. And we have customers we work with that way, and it actually works great in many cases, right? And then how do we solve the skills gap? Well, again, we focus on turnkey workflows, not infrastructure, right? So the idea is that you sign up, you choose your workflow and your scale, maybe you choose a payment method, unless you've arranged a PO ahead of time, and then you just go. I mean, that's kind of the ultimate idea of bringing cloud-based HPC to the masses. So who's actually adopting this stuff? Again, from the customers who we speak to, on the right, you basically have the industries that are really embracing cloud wholeheartedly, again, from our perspective. On the left are the ones that will soon, right? So simulation and media are actually very mature. The use cases are well understood. They know what the deficiencies are. They know kind of what the scale challenges are. So those are we don't have to kind of figure out how to do them. We know how to do that, right? And they also happen to a lot of times be on-demand or project-based, which pretty much demands that you have elastic scalability, right? So that's a very natural cloud use case. So it's no surprise that those are the ones that are embracing it initially. And then, of course, you have things like machine learning that are actually coming of age, or we've had neural networks for a long time. I'm not trying to say this is new stuff. But the current craze of machine learning is really happening in the cloud age, right? So again, the go-to delivery medium for a lot of these users is cloud to begin with, right? In the middle, you have industries where cloud makes sense, in many cases, but there are some challenges specifically around data sets. They're either very large or they just need to find some place where they have the right type of storage, et cetera. And then on the left, in the energy space, the data sets are very challenging, but also there's a huge existing investment in infrastructure, so the go-to MO there is to use what we have. Well, the problem is that oil is actually really cheap right now, and it's difficult to retain people to actually run those systems. So there's economics conditions that are actually encouraging some of these users to either look at least outsourcing, whether maybe it's not public cloud, but it's private cloud, or saying, you know what, we may want to actually look at this stuff because we can get what we need right now without having to worry about retaining 20 people to manage the cluster. Right? So I'm just going to run through a couple of like 4 use cases just to give you an example. These are customers or partners of ours, and we'll keep it brief. But one of them that I can't name is a global team of, it's an enterprise with a global team of engineers to do simulation. So they have 100+ engineers. They run primarily IcePack and Fluent, but they also run HFSS. And they actually recently acquired a small CFD software company that they had to integrate into their workflows, and they were already doing this on our cloud, so they said, you know what, we need to put this on the same cloud. And again, that not only required software as a service, but also platform as a service to be able to build this. So when we said that a missing middle myth is about unsophisticated use cases, well, this really debunks it. I mean, this is a very sophisticated use case. They're looking at, there's lots of HPC packs, 20 million plus cell meshes sizes, and they need high-speed interconnects. So the team is distributed globally. So again, cloud is a great way to allow people to collaborate globally. It's one of the big use cases as well. They're project-based simulations, so they do fluctuate. So their challenges are really performance, scale, flexibility on spend and licensing, and then collaboration with teams across teams and geographies. And they've been in production for 18 months. So it's something that's been really good for us and for them as well. And this use case is actually the USDA. There's a white paper from Intel that actually we co-authored with Intel that I'm quoting Dr. Brenda Oppert there on the right hand. I know it's a bit of an eye chart, but you can just Google Nimbix, Intel, and USDA, and you'll find the first PDF is actually this white paper. So Dr. Oppert basically says that they're getting what they need done in our cloud. They already have some infrastructure, and it's fine, and they're simply augmenting their infrastructure with our cloud. But she's basically saying, you know what, if you're doing this for the first time, just go straight to cloud. I mean, this is a respected researcher in the field saying this actually works. So there's no need for you to go off and build your own cluster to do gene sequencing, right, anymore. And for them, it was really about time to value, just not having to build out additional infrastructure, and reducing the management complexity of the infrastructure were their big pain points. This is a company that does data science as a service. So basically, you're a company and you have a bunch of data and you need to derive intelligence from it. Well, you hand them your data and you give them some idea of what you need, and they come back with an answer or some recommendations or whatever. They're basically doing analytics on your data, right? So they do HPDA and machine learning on customer data. And again, it is project-based. So some days they need lots of compute, some days they need less, right? Today it's a private cloud, and they're actually rebuilding it in our public cloud. So we do both private and public. Their big challenges are performance, scale, and this data and compute disaggregation. So this is an interesting thing that was mentioned earlier. So the commodity world looks at big data as hyper-converged infrastructure, where they have the storage and the compute in the same box. The HPC world looks at it as having network attached, or in our case, InfiniBand attached storage. And what that buys you is a lot more flexibility. You can actually turn off your compute, which, by the way, is really expensive because you're using really high-end compute, and keep your data there hot without having to go off and archive and then reload your data. And it also allows you to scale your data and compute independently. So that's a really big benefit when you're trying, maybe you're trying to do an analytic that today requires 32 servers, but the data set didn't change in size. So why provision another 32 terabytes of storage or 320 terabytes of storage when you can just use the existing data that you already have, right? And vice versa. So that's a very important consideration for them. And then this one is a partner of ours who does photorealistic rendering in real time. So they're a front end to NVIDIA's IRA technology. And they enable companies primarily in the e-commerce space as well as the design space. So some of you may have heard of Onshape. So they actually have a way to render straight from Onshape onto our cloud. And their challenges are they need lots of CUDA cores and they need K80s. Or whatever the absolute biggest GPU they can get their hands on, right? So again, even though they're not using any CPU cores barely, it's still an HPC use case because they need a lot of these things, right? And of course, they need to be pay-as-you-go. A lot of these rendering jobs take seconds to complete, but they need like 32 GPUs to do it at that speed, right? Because the customer's basically designing a piece of apparel on a website, and they want to see what it looks like with their name on it, and they can't wait 20 minutes for that to come back, right? So invocation performance is very important. They need their jobs to fire quickly and return data quickly. So how does cloud actually help deep learning? So we don't have a lot of use cases that we can talk about right now with deep learning. We've got a lot, I call it kind of the Wild West of HPC. Everybody's doing it, but we're not seeing a lot of standards material that we can turn into turnkey workflows. But we all know that training a DNN requires scale, but it doesn't run perpetually. Once you're done training it, you can shut down those 200 GPUs, right, or FPGAs or whatever it might be. A lot of the data actually is in the cloud that you're going to train it with. If you're training it on images, I mean, that's where you're going to get the image data from. Text, et cetera. All the texts ever written in human history are available in the cloud right now, right? Now, it's true, if you're using your own data, it's a little bit different. But a lot of times when you're training something on unstructured data, you're going to be using sources that are public in many cases as well, in addition to whatever else you're using. And you need to be able to rerun this training on demand whenever you do your validation, you realize, hey, I need to adjust the variables, run it again. So it has to be this thing where you just never know when you're going to be training it, but you don't need to leave it on full time, right? So looking forward, this is what we see. So economics are going to drive a lot of traditional HPC use cases to the cloud because it's a really tough case to make to say, hey, I need to spend all this money up front to maybe get it back 5 years from now, right? In today's climate, that's a tough case to make, at least commercially, right? Increasing network speeds are reducing barriers for data transfer. I mean, we heard that several times today, and it is still a problem, for sure. But also there's the adage of what's the fastest way to get a petabyte from Houston to Dallas, put it in a truck and drive it there. You can do that too, right? There are ways to get data to your service provider. Market demand continues to convince traditional ISVs. So if traditional ISVs don't adopt on-demand licensing, what's going to happen is they're going to be disrupted by upstarts that actually just do it. Because at a certain point, people are like, you know what, I don't care how good your stuff is, here's how I want to buy it. And if you don't want to sell it to me that way, I'll find someone else who can sell it to me. Because at the end of the day, that's where the business case comes in, right? And then we think that more turnkey workflows are going to enable more instantaneous domain-specific values, so we don't want to sell IT services. We don't want to sell to IT. There's nothing wrong with IT, but we want to sell to the user who's going to start using this stuff in right now, right? So that's what we're seeing and what our customers are telling us. So with that, I think I have like 45 seconds for questions. So.
Any questions? I have one in the meantime. So basically, I work with the university.
Sure.
And I view our number one task is to train students. Number two is to,
I can hear.
Number two is to support faculty researchers.
Uh-huh.
But if we outsource all our activities to the cloud, where do students learn and get enough to get jobs with companies like Nimbix and other companies in the cloud?
Well, it's a great point. I mean, yeah, we're not suggesting that, and as much as we'd love for 100% of HPC to be in the cloud tomorrow, it's not going to happen. It's going to take a very long time, if it ever completely. And the national labs are not going to dump their gear anytime soon. And obviously, if you're teaching people how to do stuff, you need the systems there. But that's kind of where infrastructure as a service comes into play. So there are clouds where you can buy machines, and you can actually teach people how to configure software on those machines. Now, if it comes down to like how do you cable, you know, an InfiniBand switch, that's a very specific domain skill that you can't possibly do in the cloud necessarily. But if you're trying to teach people basic clustering, you know, or resource management or whatever it is, there are lower classes of service in the cloud that will enable you to do that without actually procuring that infrastructure. But, you know, I'm not expecting for your use cases to be migrated anytime soon, you know, entirely. But, you know, we are seeing a lot of interest in the commercials, you know, from the private sector. So.
Hey, Leo.
Yes, sir.
Great presentation.
Thank you.
Question for you regarding the missing middle customers. Would you describe them as like IT decision makers, or are they more like the business decision makers looking for something to help them on their top line? Or?
Yeah, so they're in I guess in Microsoft terms, they're BDMs and TDMs, but they're mostly with a line of business. So you know, or a lot of times they're the end users themselves who then go and speak to their department heads and say, hey, we need this. So IT always comes into play, especially when you're dealing with a large enterprise, because they have to, you know, you have to become a vendor that they can buy from, right? So we do this all the time. We work with enterprise where we have to go through certification. But what IT is not doing is implementing. So they're simply saying, here's our security standards. You know, we need to make sure that you can play, that we can get data back and forth, that you meet, you know, the certifications that you need, and it's just, you know, a lot of check the box type stuff. But once that's done, it's really, you know, the end user, it's literally self-service at that point, right? So that's what we mean by IT projects. We're not advocating like eliminating IT, because if we were selling commodity cloud, we would. But that's not what we're doing. I mean, we don't want to manage people's desktops, for example, or their email or whatever, right? So IT has a very important place, especially with the kind of enterprise security side. But it's really about, you know, certifying and then saying, okay, this is you know, an acceptable solution, go, right? So that's what we mean by that.
Thanks.
All right. Thank you.